Rather be safe than sorry. Right. So, which one of the following pairs contains two vectors? So something that has only size and direction. Speed. What is speed, Courtney? Vector or a scalar? It's a scalar. And distance? It's also a scalar. Scalar, so it's not that. Then we have displacement. What is that, Flonnie? No. Vector or a scalar? It is a vector. And force? Force, can you have negative force? No. Force in a negative direction? Yes, when we're busy with forces, we choose a positive direction. So force is also a vector, so the answer is B. Okay, then they say there, 3 forces, each with a size of 7 Newton, acts on an object P as indicated. Okay, so there's object P. There you have your 3 forces. Now they ask the resultant horizontal force. Rita Billy, what is resultant again? Okay, so resultant is where you add all of the forces together. The resultant, and please show me with your hand, where is horizontal? Yes. So are we looking at the 7 newtons? Up? No. We are only looking at these 2 forces. Okay? We see that they are in opposite directions. So if we choose, say, to the right to be positive, then this one is going to be negative. So what is the resultant horizontal force, Tato? Well, A, yes, 0. Because they cancel each other out. Next one, it says there, 2 forces of magnitude. What is magnitude again, Hope? Magnitude. The what? No? Friend, audience, 50-50. Rory? Size. Magnitude stands for size. 2 forces of sizes 10 and 100 Newton respectively means separately, this one is this, act on an object. The minimum magnitude of the resultant force is what? Okay. Now here you have 3 scenarios that you can have. Okay. Scenario 1 is where the 2 forces are in the same direction. Okay. So when the 2 are in the same direction, so 10 and 100, what can their resultant be, Rory? 110. Okay. That is when they act in the same direction, that is the maximum that it can be. Okay, it can't be more than 110. So if you have 2 forces and they're in the same direction, 110 can't be more than that. Okay. Then we have the second scenario is when they are at an angle to one another. The angle is 30 degrees, 80 degrees, 70 degrees, don't know, but they are at an angle to one another. Okay, then it can be anything. Okay, because the angle will determine the resultant force. If this angle is like that, then it will be a certain something. If the angle is like this, it will be something else. If the angle is like this, it will be something else. Okay, so we don't know the value what it will be. Then the third option is if they are opposite to one another. Completely opposite to one another. When the angle there between them is 180 degrees. Okay, then we will say, let's say to the right is positive, to the left is negative. 110. What will the resultant be this here? The opposite to one another. What did you do here when these two were opposite to one another? Say again? They cancel each other out, or you subtracted. You said the resultant is 7 minus 7. Right? So what are you going to do here? It's 90. Okay? So that is when the two of them are completely opposite to one another, when you subtract them from one another, and that will be the minimum. The minimum that it can be. You can't subtract them any more from each other. Okay? So this one here, so if they're in the same direction, it is the maximum. If they're in opposite directions, it's the minimum. So this one here will be anything in between. So the resultant here will be greater than 90, but it will be smaller than 110. So the resultant there in the middle somewhere, when it makes an angle to one another, will be in between those two. Okay, right. So the question there is, what is the minimum magnitude or the minimum size of the resultant force? The minimum that it can be is 90. So the answer is B. They love to ask this type of question. Okay, that's why I explained it fully so that you can go through it again. Did you draw these 3 drawings? Did you write down maximum, in between, minimum? Okay, right. Question 1.4 says, consider the diagram below of a 6 kilogram block that accelerates to the right. It accelerates to the right, so it's going this way. The 6 kilogram block experiences a constant frictional force. Show the magnitude. Hope, what does magnitude stand for? The size. The size of the tension in the rope. There's the tension in the rope. Can be calculated by what? Okay. Now, you are quickly going to draw what, Tsepo? The free body diagram. Yes. Now, since we have 2 objects, I'm going to draw 2 free body diagrams. For the 9 kilogram, there I have tension going up and I have the weight going down. Or now, do I have normal force here? Why not? It's hanging. It's not resting on a surface. If it's touching a surface, then there's normal force. Okay? Then the 6 kilogram block. What forces will I have there, Zara? Force applied, tension. In which direction? What is that direction? To the left. So, but ma'am, isn't the force applied to the right here? Because, remember they say it accelerates to the right. So if it's moving to the right, it means friction is to the left. While we are there, make a quick note for yourself. They love to ask the definition of frictional force, kinetic frictional force, and static frictional force, and normal force. Those 3 definitions we didn't practice a lot this year. They love to ask those. So go study them. Study. Okay, so now they ask for the magnitude, the size of the tension in the rope. Okay, now the tension we have at two places. This one and this one here. Okay, it's the same tension because it's the same rope. So you can use any one of those two to calculate tension. Can I say this tension is equal to this gravitational force, Sebabatso? Why not?
Because the weight of the object is not the same.
The weight of the object? No, that's not why. So my question is, can I say this is equal to that? So can I say T is equal to the mass times 9.8? Say again? Can't hear? Call a friend. Who are you calling? C, yeah? Let me ask this question. Which law are we looking at here? Which one of Newton's laws? No. Oh, you said second law, go for it. In words. I will help you. If net is equal to m times a. When a. No. When a. When a.
Net force acts on an object. The object will accelerate in the direction of the force. Acceleration is directly proportional to the force and inversely proportional to the
Mass. Hold on. So we are busy with Newton's second law. How do we know that? Because they say it accelerates. So if I look at the 9 kilogram block, I'm going to say F net is equal to m times a, and it's accelerating to the right. So it means this one is accelerating up. Yes? Yes. So I'm going to choose up to be positive. So it will be T minus Fg is equal to m times a. So I cannot say this is equal to this because there is acceleration. I cannot say that. Okay. So it's definitely not a. Okay. So let's see. You see here they speak about 30 cos 20, 30 cos 20, 30 cos 20. Where do they find that, Niakalo? That either spot. Oh, at which block? Sorry, the 9 kilogram or the 6 kilogram block? The 6 kilogram block. So basically with these options, they tell you, please look at the 6 kilogram block. Okay, right. So for the 6 kilogram block, here we are. We see there's one that's at a weird angle, right? We do not like that. So we split it up into its perpendicular components. Then what's the next thing I do again, Kutlana? You are special. You're in my class. Nikalo? Highlight. Where you are. Okay. So where is T? T is in the horizontal plane. So I'm going to look at the horizontal forces. Yes? Yes, that's your question, Papa. But where did I say you must make notes? But anyway, you can highlight there, but also make notes there. Okay. Right, so if I look at these forces. Okay, so this here was for the 9 kilogram. I'm not looking at that anymore. Now I'm looking at the 6 kilogram block. Okay. For the 6 kilogram block, F net is equal to m times a. And it's accelerating to the right, so I choose to the right to be positive. So I have here the x component. Okay, how do I calculate the x component? Well, this is 20, this is 30, so it is close to it, so it is adjacent, so it's the cos. Yes? You remember that? Let's make a quick summary here. The cos of 20 is x over 30. So x is 30 cos 20. Rings a bell at the back of your mind. We did 1 million of those. Not 1 million, but at least 100. Okay, so it's the thing to the right. There's x. There's 30 cos 20 degrees. Minus the things to the left. Yes? So minus t minus fk is equal to m times a. Sorry, instead of saying m, which mass am I looking at? I'm looking at the 6 kilograms, so I'm going to say minus equal to 6 times a. Okay, the question is, what is t equal to? Can you see t is negative t? So I'm going to take t to the other side to make it positive. So I'm going to leave here, I have 30 cos 20 minus fk minus 6a is equal to t. Check that you agree with me. So that thing, then I said minus t minus fk is equal to 6 times a, because I'm looking at the 6 kilogram block. And then I wanted t, because I say the tension is equal to, so I took the t to the other side to make it positive. And then I took the 6a to that side and it becomes negative. So that, minus that, minus that. Okay, let's see. Do we have an option like that? 30 cos that minus fk minus 6a. So the answer is B. Okay, now before I go on, how long did this first question take me? Say how much? 2 minutes. Did it really take us 2 minutes? I think when you did it on your own, it would have taken you, let's say, 30 seconds. Because you got to the second option and that was the answer and you go. So you technically have 90 seconds left for this question. This question also counts 2 marks, so also 2 minutes. But now because of the easier question previously, now you have more time. Now you have 3.5 minutes for this question. Okay, so take your 3.5 minutes for this question. Don't think, oh, this is taking too long, I'm wasting time. Okay, let me just go on. Okay? Take your time with these questions. Because even though this question took long, it's not a difficult question. Okay, because how many times have we drawn free body diagrams? A lot. How many times have we started with F net is equal to M times A? A lot. So it's not a difficult, it's the same pattern over and over and over and over again. Okay. Right, next one, it says there, Vuyo, the driver of a minibus, moves at a constant velocity on a horizontal path. He saw that the sliding door of the minibus was open. He suddenly hits the brakes and the door closes. Have you been in that scenario before? No? Where you stop and the bus closed. Okay. Which one of the following physics law or principles best explain why Vuyo could close the door? Okay. Now we did not this example, but I explained a lot of these examples at the beginning of the year. Where I said, I think we had a cup with water with a coin. And I quickly ripped off the paper and the coin dropped in the water. We definitely did that one. Yes. Okay, the other one that I explained was the toilet roll, where we said you're on the toilet and you have two options. You either rip it quickly and the toilet paper comes off, or now my finger, or you do it slowly, like this, and the toilet roll goes on and on, or you drop the toilet roll and it runs underneath the door and it goes on and as you pull it more. Yes, have you been in that scenario before? Yes. I think you're not a human being if you haven't experienced that. Okay. Right. So, or we said when you are in a car, in a minibus, and you're driving at a constant speed and suddenly it brakes, what happens to your body? This. Right? So the same idea. Now it's not your body, now it's this door. So it goes, and it breaks, and it goes on the door. Okay, which law is that? Newton's first law. You said it, now say it. The body will. Unless a non-zero net force. Yeah, net force is fine, but you need to say non-zero. No, it needs to be a non-zero net force. So net force can be zero. So you have to say net force, but you have to say non-zero net force. Can't just be net force. Say again? What is a net force? What? No, then it's wrong. It needs to be non-zero net force. Look at past papers. It will say non-zero. No, they say non-zero resultant or net force. So it's not non-zero resultant or net force. But the or part is not on the non-zero. The or part is on resultant or net force. So you can say unless a non-zero resultant or unless a non-zero net force. You see. But the non-zero must be there. Okay. But like I said, it's Newton's first law. So the answer there is C. Okay. Next one, it says, the diagram below shows a wooden block which is pressed hard against a wall by a horizontal force. Which one of the following represents the action-reaction force pair according to Newton's third law of motion? Okay, now I'll quickly scan. Why? Because there's actually three forces acting on this block. It is weight, then it's the applied force, and then it's like the normal force of the wall on the block. Right? So those are the three forces. So I'm quickly scanning which one are they looking for. The weight, force F, weight and force F. They're not even in the same plane. So it cannot be those two. Okay. Force F, force block on wall. Okay. Force block on wall. Force of wall on block. Force. Okay. Right. So they're looking at force F specifically there. Okay. So force F, when they ask action, reaction, or when they speak about Newton's third law, then you're going to be very thorough, very clear in your subscripts on the block. Okay? So what is force F? Force F is the force of hand, or with the force hand on block. Okay, so then the action-reaction pair is where you swap these two things around. Okay, so the action-reaction pair is the force of the block on the hand. The hand or the, I don't know what else can push it on there, stick or whatever. So force F on the block, the force F on the block, and the force of the block on the wall. No. Okay, so it's not that one. Because here, they didn't speak about wall. Okay, so if they speak about wall here, they must speak about wall there. Right, next one, the force of F on the block, F, the hand or whatever, on the block, and the force of the wall on the block, again, no. Okay, let's just check. Next one, the force of the block on the wall and the force of the wall on the block. Let's check. So now they're speaking about this normal force. Okay, so they're speaking about the force. What is that normal force? The force of the wall on the block. That is that normal force. Okay, so if I sit on here, what is the normal force basically? It's the force of the chair on my butt. So the reaction pair will be butt on chair. So the normal force is actually the chair on me. Okay, so here the normal force is the force, that force there, is the force that the wall exerts on the block. So the wall on block. So the action-reaction pair will be the force of the block on the wall. So I swap those two things around. Okay, so let's check. The force of the block on the wall, and the force of the wall on the block. So it must be D. So action-reaction pairs are always when you swap those two things around. Okay, 1.7. It says there, which one of the following graphs shows the correct relationship for Newton's second law of motion? Okay, let's just see what do they have. They have acceleration, mass. Now I must just be careful. This is 1 over mass, and just mass. Okay. Where are we with our questions? Relay, it's your turn. Say Newton's second law again, but just the second part. So just the second part where you say from acceleration.
Acceleration is directly proportional to the force and inversely proportional to the mass of the object.
Okay, so they say acceleration is inversely proportional to the mass of the object. Yes? Okay. Now, they are giving two types of graphs here. They're giving acceleration versus 1 over mass and acceleration versus mass. Okay, I'm first going to look at this one. If they give it to you like this, where it's a straight line like that, then we read it as acceleration is directly proportional to mass. Is the acceleration directly proportional to the mass? No, so it cannot be D. Okay, now I have to look here. Which one can it be? If I have it like this, then this is on my y-axis. This thing is on my x-axis. Okay, so y-axis, x-axis, like you can see there. I can read this in two ways. I can either say acceleration is inversely proportional to mass, or I can read it, acceleration is directly proportional to 1 over mass. Acceleration is directly proportional to 1 over mass. I can read it to you like that. Okay? So where do I find in here acceleration is directly proportional to 1 over mass? Option B. Right? So where you have acceleration is directly proportional to 1 over mass. So that is why the answer is B. Okay, ek het dit gaan neerset. Ja, wat voor? O, ek het dit nie highlight nie.
Wat moet dit vir sê?
Nee, ek sê vir Charlotte het verander. Ek het dit ingesit. Okay, grade 11s. Your homework is a question 2. Question 2. Only question 2. Yes.
This question, if they give you a graph saying your acceleration and then just your normal mass, but the graph has like a curve.
Then that one is cool. Yeah. Okay. I will hopefully give to you the question papers during the course of the day so that you can do question 2. Let me just check. Where are you guys after first break? After second break. Sorry, second break. Where are you last period? English. Okay, then I'll bring it to you to English. Ja, asseblief.
Ek het nou daai geld vir daai tennis vir die dag.
Nee, maar dit daai dag betaal. Daai dankie. Daai dag wat jy daar aankom, betaal jy vir want julle is onder 17, hè? En julle gaan speel dan in waar is onder 17? Spreek ek is in Sasol. So daai persoon want jy betaal vir die van die bane vir balle, vir sal jy so vir daai mense.
Maar jy vreet alles wat jy verkoop vir my.
Jy weet?
Jy vreet alles wat jy verkoop vir my.
Ek hoop so.
ID.
Hoop so.
Okay.
We will see. Ek dink dit tot 4 maandag in Woensdag.
Okay.
Wat is jou hemp?
Ek is vergeet.
Ek dog ek vra 'n verantwoordelike mens. Nee, bring môre. Goeiemôre Glatiens. Julle kan sit. Haal asseblief jou huiswerk uit. O, jene hierdie